everyone, I'm Loukik, a computer vision engineer at Plainsight, and welcome to this OpenFilter tutorial. So today we are going to make an app that tracks the changes in the number of people in a video or a stream. You can imagine how this could be a very important step in various monitoring workflows. So for starters, you just taken a video file and a requirements.txt. Let's quickly install this. And so every OpenFilter app depends on a basic building block, that is a filter. And a filter is essentially a Python class that contains the custom code for applying frame-wise computer vision operations. So let's just define our filter here. So every filter has this basic boilerplate code which will go through quickly. So the filter inherits from the filter class in OpenFilter, and normalize config essentially normalizes all the configurations that you pass to the filter. So for this filter, we just have the bool, that debug bool configuration. The setup function essentially acts like an initialization where you initialize certain variables that will be used for this class, and the process is where the custom Python code goes to. And in order to run this filter, you need to connect it via a filter pipeline. So let's quickly see how that works. So this is the code for connecting the filter via filter pipeline. We don't have the DB filter right now, so I'll just quickly comment out this. And yeah, so every filter pipeline has this configuration. So the first filter as generally is a video in filter that takes in videos from any type of video files, for example MP4, MKV, or whatever you can think of, or even an RTSP stream, and it passes that on to a different stream from where our YOLO filter will pick that up and pass, like, do some custom operations and pass the outputs to a different stream. And the webvis is essentially a stream like that you can visualize on your local host, and like you can annotate stuff on the video which can be then visualized in your live stream. So let's quickly see how that works. Let's run this script, and here you can see it says you can visualize the output here on localhost 8000. So let's quickly see that. And yeah, right now we are not doing any operations on the video, so it can be seen just like a raw video stream can be seen here. We have the empty filter running, so let's do some operations in this filter. So YOLO filter, what essentially this filter does is it detects the objects in every frame and passes it downstream to a different filter. So for detecting, let's just create a script real quick. So detect objects.py, and what this script will essentially contain is a function. Yeah, so as you can see, I've written this function earlier. So this function takes a NumPy image array and it uses the YOLO model to detect all the objects in this array. It loops through those objects, like converts it into a dict which has like class and confidence for each object, and passes it down to the next filter, like, and returns the list essentially. And now we'll use this function in the YOLO filter. So let's quickly import it. Yes, and here We'll first extract the frame from frames object. So the frame is inside the main key, and we'll extract the numpy image. And we'll get the objects from this function, and we'll pass this objects to the frame, which will then go downstream, which is then returned to the downstream filter. So I'll just log this here to so that we understand what's getting passed. And let's rerun this script now. And it's downloading the YOLO model because it's the first time. And now you can see for each frame the objects, detected objects, are getting logged here. But for our functionality, we just want it to pass it downstreams. So we are logging just for visualization right now. And so now essentially the YOLO filter is done. All it does is detect objects in each frame in the video and pass it downstream. So now that we have this YOLO filter that detects objects and sends them downstream in this data dictionary, we need a downstream filter that processes this objects dictionary, detects the change in the person count, and logs it to a DB. So for that, let's create another filter, that is filter DB. Okay. And again, we'll need the boilerplate for this. And since it's a filter that connects to a DB, we need a connect DB function here. So all this does is loads the n variables and connects to the Postgres DB. And we need the connection here. And since this filter will count the number of persons every frame, so we need a last person count variable that stores the person count in the last frame. So if the person count changes, we have to log it to a DB. And let's extract the object that we stored in the YOLO filter. And so the next thing we do is we count the number of persons in the frame, and we count the number of persons with a confidence greater than 0.7 because we need to be confident that the detected object is actually a person. And what next we'll do is, if the count of the person class is not equal to the count of the last person count variable, that is this, then we log the change to the DB and we set the last person count to current person count. And for that we'll need this log change function that we can define here. And this is like normal SQL, like insert the query. If it's an increase, then like change type is increase, and if it's a decrease, then change type is decrease. I'll quickly show you how this DB looks. It's it just simply logs like the current count and if the count has been increased or decreased and the timestamp. So yeah, I think we are pretty much done here. But let's just visualize all the like counts of different objects on that was detected by YOLO. So we create this text overlay and we put this text on the image. For that we'll need the image here. Image is this, and put the text on it, and we recreate the frame's main object and put the updated image inside it and the frame.data, so we don't lose the objects data that was in this dictionary. And yeah, one important thing is we need to define the n variables so that we could connect to the database. And let me quickly get those. And now if I run the script, it should detect changes to the count of persons and log it to the database. So we can see what's getting visualized here. You can see the counts are changing. And yeah, in this video there's just one person who appears and then disappears quickly. So if we see the logs, we should get that, yeah, we got two new, like an occurrence event and a decrease event, that is person count went from 1 to 0. How we created this simple computer vision pipeline using OpenFilter within 15 minutes, I guess. And simply changing this source to an RTSP stream will like help you apply the same person count functionality on a webcam RTSP stream. So if you have like a CCTV camera that points at your front yard, you can use this same example and detect whenever there are people in your front yard. So that's pretty cool. And this was like a simple pipeline that can be demonstrated by this diagram. Like we got a video in where you take an RTSP stream or a video stream, you pass it to the YOLO filter that detects objects from that stream. Then the detected objects are passed downstream to the DB filter where it does the counting of classes. And if the person class object changes, the number of people for the person class changes, it logs it to a DB. And WebWiz just like visualizes all the different object types in the frame. And this was like a simple pipeline, but you can imagine how we can create different complicated pipeline setups like these using OpenFilter. And I think this is where the real power of OpenFilter lies, where you have to process like multiple video streams at the same time, or you need like output from model 2 as well as output from model 1 for a filter. And yeah, I would love to hear from you guys what kind of examples you want to see next, or if you create some complex examples like this using OpenFilter. So that was all for the tutorial. See you next time.